some of the tools you're going to need for this job, this repair, well, is at least one pipe wrench, a torch, a hammer, obviously, to get inside the wall. We're using pecs, so we needed something to cut the pipe. We needed some channel locks. I always do a big and a small. I'm going to end up using this tool for my PEX fittings, just simply because it's going to make it a little easier. It's a 7/8. That's a Craftsman. It's a newer style apparatus of a wrench that they use. We needed a sawzall. Of course, you need pipe sealant. Torch, solder, flux, because downstairs we got copper lines we're going to be tapping into. We needed something to cut the pipe, which you can use your sawzall, or if you got tube cutters you can use those. And then I think that's it. This is a galvanized system. You're going to cut into it. When we take it apart and put it back together, you're going to want to try to take off your aerators to relieve the air. And in a lot of cases I say only run the hot water, because if there's air in the cold water, depending on where you're cutting into the system, it may send the air through the water heater, and then you don't have to deal with lime and debris. Now on this one it's not going to do that, so I'm going to try to turn it on at the bathtub, because the ports inside the bathtub faucet are normally bigger, so any pieces of rust can go through and get freed up and not clog. If it does clog the faucet, you're gonna have to take it apart. So when you turn the water on, turn it on slow. Try to let the water go into the system real slow, so that it don't knock loose any more than what already has been knocked loose. I think that's it. So we cut that hole that we had in our in the soffit. We hit a big, like they put wood in here, big bunch of wood. So we almost went to the side around the living room and cut that hole in there. Then I was like, well, let's go ahead and cut in that wood and see what we got. Well, it's kind of probably good that we did. There's the lines. We would have been able to get to them from there. It just would limit us, because up there is more floor joist, so up there we wouldn't have been able to do anything. But then we get around inside here, and there's the break. So that right there is a freeze break, which don't normally happen on galvanized, but it was in the winter time and they didn't have no heat at all in here, so it ended up happening. So we're in here inspecting the rest of the lines, just making sure, we don't want to come up with a plan of attack, start repairing that one crack and then find that there's more. Of course, I look down through here, the lines look real good, considering they're old galvanized. But overall everything looks pretty good in there. It looks dry down there. So we're just sitting here hanging out talking about it, and I get to looking and I seen the drywall. This house is funny. They put drywall and then did the plaster, so it must be a way they done it in the 60s or something. But anyway, I got to looking at that drywall over there, and it's obvious. I would have thought maybe bugs had ate it if it didn't look like it was wet. So then I reach around that pipe and I can feel a crack on it. So that means this section that's going from here to the basement is damaged. The other thing is, I look over there on that other line and I can see water coming out of the wood. Ever so slight. Let me see if I can zoom in on it. Right there. So that's water that has seeped out of the wood. Now I would have thought that crack there would have sprayed over there, except for the fact that none of that looks wet. So what we're going to do is we're going to cut it somewhere here, maybe unscrew it right there. Same thing on the other line. And then we're just going to try to fish some new PEX piping up from the basement in hopes that this is our only hole. But I want to point that out, that it's probably a good idea to look over everything, you know, because we would have just made a repair on the one side and then come to find out that the other side's messed up too. And then in that case, you might as well just ran a new line. So it would have been a waste of time. So thoroughly inspect as much of it as possible. We opened our hole up a little bit bigger. We have to try to cut so these lines don't vibrate a bunch, and we're going to cut on that side of the T so we can still unscrew that fitting or that pipe from the T, and then hopefully work out of the T. Obviously one of these is hot, one of them's cold. From the earlier video, or from the video, you can tell we're just planning on doing both of them. So I've got up in here to where we cut them lines out. Started trying to unscrew that one. If I put too much pressure on it, I'll break the T at the threads there or there. So we gotta be careful. The problem with this one is it's starting to egg shape. I don't know if that gives you an idea of what it's doing, but instead of unscrewing, it's flattening. So I'm gonna heat the threads up right here a whole bunch with my torch and then try to unscrew it, because I really want to work off them threads. And a lot of the one over there, it's gonna be a little bit harder to mess with because it's closer this way. I mean, there's already not that much room up in there, so it's hard to get a pipe wrench in there. I don't think I have a 14 on the truck. I don't know, maybe I do, but either way, it's putting up a fight. It's not coming out like it should. Normally they'll either unscrew real easy, like if they were dripping at the threads, then they would either snap or unscrew real easy from the threads. But you run into stuff like this. So one of the tricks I'm going to try is putting a torch on it to heat it up and then try unscrewing it. Okay, putting the heat on the one did work. This one has already started spinning, and I didn't have to do anything to it. One good sign, because whenever you mess with galvanized, you're worried about every other joint. Just a simple vibration of cutting the pipe, definitely turning it. You can snap a fitting or make another joint leak. Heck, we pulled down on these because these were the sections that shot over from here over to there. And we pulled down on them and you can see that they snapped. Heck, just looking at it, you can see this side of it's black and this side of it's still got a metal look to it. So this side was probably stronger than that side. Yeah, it's there. Give me a second, I'll grab it. Now this one is the piece that I had to heat up and pull out. You can see it's still steaming. You look in there, you can see all the... You see all the rust inside there. But overall, the threads are in really good shape. Like normally these threads are all rotted and corroded. Normally halfway through unscrewing it, those would snap. So we're in pretty good shape, considering. A couple more things I thought about. Being that this is plastic piping, it is going to jar around when faucets are turned off and on. So you're going to want to try to anchor them some way, somehow. And I would say, I mean, like that, they're going to hear that when the toilet shuts off or kicks on. So plastic piping should have hammer resistors in it or loops on the inside. Or loops, you loop the line to kind of create that hammer resisting effect. But yeah, if you can anchor these some way, somehow, tie them down, put two nails in next to them and put the nails over top of the pipe, whatever you want to do so that they're not jarring around. If you only use one crimp ring, you're going to want to go in that, roughly in the center of where I put mine. You know, in the center of that whole joint. So like I said, on these I went ahead and put two of them just for good measure because it's in the wall. Teflon tape. That blue stuff I use is real thick. If you get the little cheapo stuff from the hardware store, sometimes it's thin. You just don't want to put enough on there to where you can, if it's the real thin stuff, go around it at least 4 to 6 times. If it's that the thicker stuff, I use a brand called Hercules. If it's blue, chances are it's going to be the same brand, or Monster, I'm sorry. I think it's made by the same people that make Hercules stuff. At any rate, it's Monster, it's blue. Go around it, you know, 3 to 4 times. You could probably get away with 2 with blue stuff. I don't normally like Teflon tape in freshwater applications. Sometimes it's nice to use. Being that we weren't doing any heat, you know, we weren't soldering anything up there, we very well could have put some pipe sealant on them, liquid pipe sealant. It don't have to be Teflon. Years ago, that's all I used. And then I started, they started making this real thick Teflon, and I liked the way it was, so I started using it. Hey, if the video was useful, you liked it, you saved some money, I explained it good, whatever it may have been, like it, subscribe, share it, you know, one of the 3 or all of the above. Thanks for watching. So now what I've done, yeah, give me 1 second. What I've done to make this real easy, screwing down these PEX adapters. They're MIP threaded, nail iron pipe threaded by PEX. All this is 1/2 inch. So one of the things that I grabbed, and it just happens to be a tool that I have, I don't use a whole lot, but it's a Craftsman, and it's made so you can take nuts off of bolts, and the bolt will shoot through the actual socket. So what I'm going to do to put these on up there so I don't have to fight with my channel locks is do that. Put it on in there, put some Teflon on it. Now remember, when you do your Teflon, so that it don't back off of the fitting, when you're starting to tighten it in, you have to put it up right like that, look down into the threads, and go clockwise. So when we put our Teflon on, we're going to want to look at it. Look at the threads, and then wrap it clockwise. Because if we put it on the other way, when we're tightening it down, it's going to unravel it off of there. So just a little tip, something to think about. We're in the middle of pushing our PEX through, and there it is. So that's how easy it is. It's starting to happen for us. So, all right, John, give me 1 second. No, I do have 2 guys. Yeah, there's both of them. We got them. Okay. Okay, that will be good on that one, and this one will be good on that one. Now I think if you look at the joist down, or the ceiling down there, they're marked which one's hot and which one's cold. I guess so we can, well, I guess it don't matter, we just hook them up the same way. You know what I mean? Never mind. I'm tripping. So I pulled out enough slack that I'll have enough pipe to hook in to both sides. Only because I've got him down there hooking it up downstairs. You know, if it was just me by myself doing this, which is sometimes hard when you're having to fish stuff through walls like that. But because he's down there hooking it up, you know, I want to have extra here. If it was just me, the extra wouldn't matter. I'd go and put my male adapters on, which are again 1/2 inch MIP by 1/2 inch PEX. So I'll put those in, and I'm gonna connect these, and then downstairs will be connected, and then we'll be ready to turn the system on. It's a done deal. Now it's gonna be real hard to see, so I'm gonna go ahead and record it, but I don't know how it's gonna work out. There's 2 different kind of crimp rings. You've got black ones that are made out of copper, and then you've got ones that are just copper color. It takes an entirely different tool than this. And then you've got the ones that are stainless steel, and that's what I'm going to use today. I've got both on the truck, but the stainless steel ones are nice in the applications where you don't have a whole lot of room, because the copper ones, they have to open up. The levers, or the jaws have to open up so much that these levers on the handles or whatever have to spread out so far that you need the room to get in there. I prefer the copper straps, or crimp rings. I really do. They seem to crimp a lot better. They smash the pipe more. I just prefer them. They're cheaper. Now, I've never seen them fail, provided they're put on right. The stainless steel, it's not very often that these fail. Some people call these cinch crimp. I guess it's not very often you get them on the pipe crimped, everything good, and then they fail. When these do fail, what happens is these side pieces right here, that's really what holds them on. So when you start pinching this, it closes it down and it holds onto it over on this side. At any rate, the stainless steel are pretty good. You only need one crimp ring per joint. If you wanted to go the extra step, you can put 2 of them on. You just have to make sure that they're pushed as close to the fitting as possible. Because this second one's barely, it's going to be on it, but it's only going to be like halfway on. So that's the key thing. Another good thing about pecs, when you put these on, you can turn them and the pipe. Because the way that they seal is they crimp into that adapter, and you see how the adapter's rippled, or it's got little rings around it. So essentially what happens is the plastic pipes get smashed into each one of those rings, and that creates your seal. Eventually through the years these rings may wear out, and then water will slowly start getting through. But at any rate, they're great. And it's going to take, like 15, 20 years, maybe even longer for that to happen. So, but that's what we got when we put 2 rings on it. You can kind of see the end wanting to stick out, but realistically you can't get them that close. So I'll normally crimp one, use channel locks to spin that ring upward, and then do another. Again, I'm just doing that as an extra safety precaution, because this is inside the wall. I'm going to go ahead and try to show myself or record myself doing this. Again, I don't really know if we can see it real well. Yeah, we can't really see there. Let me see if I can move further back, and then I can give you an idea of what it looks like when I crimp them on. PEX is one of the easiest, yeah, there you go, easiest pipes or piping to work with. They've got CPVC out there, which I do not like at all. There are applications where CPVC can be nice and useful, but PEX is good. Now PEX does freeze and break. A lot of times, in some cases, it will swell and not end up breaking. Now copper does that too, but more than likely when copper swells, copper breaks. CPVC gets hairline cracks all through it. I hate CPVC with a passion. So anyway, that little space inside there, you have to get that piece of the ring inside of it, and then as you tighten the jaws down, it closes, so it pinches the ring. Again, I prefer the copper, but it just wasn't good to use here. Okay, so there's one. And I'm going to take my channel locks and twist that a little bit so that I can potentially get the other one on. Yeah, it didn't go a whole lot, but it should have moved enough for me to do what I need to do. Sometimes I'll get my tool on, then I'll bring it to the fitting. And right now I'm using that 2x4 to help me crimp it. Okay, and then that's it. The only thing you do have to worry about on the copper ones is that it's crimping it straight on. Sometimes the copper rings will crimp it on at an angle, and that will cause problems. But you know, again, for the most part with the copper rings, you cannot go wrong. It's the better ring to use. As a homeowner trying to do this, just get the stainless steel, because you're going to buy one tool, 40 bucks. You're going to buy whatever rings and stuff that you need, but that tool is only 40 bucks at the hardware store. I mean, maybe 50 at the most. Whereas they do have the crimping tool. It's a little more expensive, and some of them do 1/2 inch and 3/4, but some of them don't. So just get the cinch crimp, or whatever you want to call that one, that particular tool. Get it, and it's going to do all the sizes for you, the 3/8, the 1/2 inch, the 3/4. So you got one tool that will be useful for anything you need to do in your house. Couple more things I thought about. Being that this is plastic piping, it is going to jar around when the faucets are turned off and on. So you're going to want to try to anchor them some way, somehow. And I would say, I mean, it's like that. They're going to hear that when the tool shuts off or kicks on. So plastic piping should have hammer resistors in it, or loops on the inside, or loops. You loop the line to kind of create that hammer resisting effect. But yeah, if you can anchor these some way, somehow, tie them down, put 2 nails in next to them and put the nails over top of the pipe, whatever you want to do so that they're not jarring around. If you only use one crimp ring, you're going to want to go in that, roughly in the center of where I put mine. You know, in the center of that whole joint. So like I said, on these I went ahead and put 2 of them just for good measure because it's in the wall. Teflon tape. That blue stuff I use is real thick. If you get the little cheapo stuff from the hardware store, sometimes it's thin. You just gonna want to put enough on there to where you can, if it's the real thin stuff, go around at least 4 to 6 times. If it's that the thicker stuff, I use a brand called Hercules. If it's blue, chances are it's going to be the same brand, or Monster, I'm sorry. I think it's made by the same people that make Hercules stuff. At any rate, it's Monster, it's blue. Go around it, you know, 3 to 4 times. You could probably get away with 2 with blue stuff. I don't normally like Teflon tape in freshwater applications. Sometimes it's nice to use. Being that we weren't doing any heat, you know, we weren't soldering anything up there, we very well could have put some pipe sealant on them, liquid pipe sealant. It don't have to be Teflon. Years ago, that's all I used. And then I started, they started making this real thick Teflon, and I liked the way it was, so I started using it.